Hi everyone! In this video we're going to talk about angles in radian measure, angles in standard position, and coterminal angles. One radian is defined as the central angle formed in a circle such that the radius length is equal to the length of the intercepted arc. So one radian, everyone, is about 57.3 degrees or so. Okay, that's the definition of one radian. But we'll keep this simple. Pi radians is equal to 180 degrees. And so if we have to convert from degrees to radians, we just multiply 180 over pi over 180. And if we wanted to convert from radians to degrees, we multiply 180 over pi. So let's do some examples. Let's start with 30 degrees. If we want to convert that to radians, we multiply 180 over pi, and 30 goes into 180 6 times, so we're going to reduce this to be pi over 6. So 30 degrees is pi over 6 radians. Let's try 45 degrees. Okay, we multiply 180, pi over 180. 45 goes into 180 4 times. We can reduce that to pi over 4. And lastly, let's convert 60 degrees to radians. We multiply pi over 180. 60 goes into 180 3 times. We're going to reduce this to be pi over 3. So 60 degrees is pi over 3 radians. I'm going to write all these down. 30 degrees equals pi over 6 radians. 45 degrees equals pi over 4 radians. And 60 degrees is pi over 3 radians. Well, now let's convert from radians to degrees. To go from radians to degrees, we multiply 180 over pi. So let's say you have 4 pi over 3. And you want to convert that to degrees. Okay, you just multiply 180 over pi. Now 4 times 180, that's a big number. So an easy way to do this, look at the 180 and the 3. We can reduce that. 180 over 3 is 60. Pi's cancel. 4 times 60 degrees is 240 degrees. So 4 pi over 3 is 240 degrees. Another way to look at this, though, is, you know these. These are common angles. And you have to figure out 4 pi over 3. And you know that pi over 3 is 60 degrees? Well, okay, you can just say 4 times 60, which is 240 degrees. That's another way to look at it. For example, alright, see how 30 degrees is pi over 6? Say you got to convert 5 pi over 6. Well, that'd be 5 times 30 degrees. 5 times 30 is 150. Be 150 degrees. Now we're going to talk about angles in standard position. Angles have an initial side and a terminal side. And when angles are drawn in standard position, the initial side always lies along the positive x-axis right here. This being the x-axis and this being the y-axis. Its vertex is right at the origin, and it rotates in a counterclockwise direction if it's a positive angle. So let's sketch 45 degrees. Start here, rotate about 45 degrees. There's your terminal side. You can draw an arrow right here if you want to indicate that direction. And this is about 45 degrees, which is pi over 4 radians. All right. So there's a sketch of pi over 4 radians, or 45 degree angle, in standard position. Angles can be negative though. So let's say we have an angle that's negative 45 degrees. Negative angles, still in standard position, rotate in a clockwise direction. So start here, initial side, rotate 45 degrees this way. Alright, that's negative 45 degrees, or negative pi over 4 radians. Okay. A couple more sketches in standard position. How about, well, let's do pi radians in standard position. What would that look like? Alright. Well, initial side here, and if it rotates 180 degrees, boop, you bet it's a straight angle. So that would be pi radians. And what would 2 pi radians be? All right. 2 of those. So if you have to find an angle and sketch an angle in standard position that rotates 2 pi radians, that's 360 degrees, and its terminal side lies right on top of the initial side, right there along the positive x-axis. So that right there would be 2 pi radians. Just remember, if it's a negative angle, in standard position, it rotates in a clockwise direction. Okay? So that 4 pi over 3 I mentioned earlier, which was 240 degrees, if we had to sketch an angle that was negative 4 pi over 3 radians, okay, when we start here, we'd have to rotate negative 240 degrees. So we'd go this way, well that's 180 degrees, we just have to go about 64. Go. And when that would be negative 4 pi over 3 radians, or negative 240 degrees. Initial side, terminal side, when the angle's negative, it rotates in the clockwise direction. Alright, so that's angles in standard position. Now let's talk about coterminal angles. Coterminal angles are 2 angles such that they share the same initial side and terminal side, but possibly different rotations. So let's look at, how about pi over 4 radians, which is 45 degrees. If we have to find a coterminal angle with 45 degrees, all we have to do is add or subtract 360 degrees. That's it. We will just add or subtract 360 degrees to find a coterminal angle with this angle. Now, if you want to do it with radians, you will add or subtract 2 pi, because 2 pi radians is 360 degrees. Pi radians being 180 degrees, 2 pi radians being 360 degrees. So this is how we convert. So I need a coterminal angle with 45 degrees. I can just add 360 to it. And what's 45 plus 360? Oh, we get 405 degrees. Now what would that look like? Alright, starts here. Right? Rotates in a counterclockwise direction. So we'd go the full 360 degrees, and then it would land right there. So that's 405 degrees. Notice, initial side, terminal side, same position. Coterminal angles. Hey, let's do this in radians also. It's not that bad. And when we have to take pi over 4 and add 2 pi, you just need a common denominator, which would be that 4. So I'm just going to multiply 4 over 4 to this 2 pi so I can add these fractions. I get pi over 4 plus 8 pi over 4, giving me 9 pi over 4. You can rotate the other way though. So here's pi over 4, which is a coterminal angle with 9 pi over 4, and 405 degrees. That's 9 pi over 4 too. We can rotate the other way. So what if you subtracted 360? Alright. 45 degrees. Subtract 360, you're going to get negative 315 degrees. Or pi over 4. We're going to subtract 2 pi, which was at 8 pi over 4. Gives me negative 7 pi over 4. So these are the same angle. And this angle is coterminal with pi over 4. What would it look like? Well, initial side right here, but it would rotate in a clockwise direction. So we'd rotate this way, come back around this way, stop right there. Once again, initial side, terminal side. This is your 315 degrees, but it's negative. It's negative 315 degrees, or negative 7 pi over 4. Okay? Sometimes you don't have to make a sketch. If you just have to find the angle. Let's say the angle was 800 degrees. And you need a coterminal angle that's between 0 and 360 degrees. Alright, just continually subtract 360 from this and from the next one until you get there to an angle between 0 and 360. I'll show you what I mean. When I subtract 360 ones, and when I get everyone's, I get 440 degrees. So 440 degrees is coterminal with 800 degrees. But I want an angle between 0 and 360. Just subtract 360 again. 80 degrees. 80 is coterminal with 360. Excuse me, 80 is coterminal with 440. 440 is coterminal with 800 degrees. Let's say it was in radians though. Alright. So let's say it was 14 pi over 3. You have an angle that's 14 pi over 3 radians, and you need to find a coterminal angle with that in radians. Well, we just subtract 2 pi. You can also add 2 pi if you have to find a coterminal angle. But let's say the direction said the angle has to be between 0 and 2 pi. I'll just subtract 2 pi from this. I need a common denominator, so I want 14 pi over 3. I multiply the 3 over 3, I want just so I have common denominators. I get 14 pi over 3 minus 6 pi's over 3. And that gives me 8 pi over 3. So 8 pi over 3 is coterminal with 14 pi over 3. But I want an angle between 0 and 2 pi. Well, I'll just take this 8 pi over 3 and do it again. Subtract the 2 pi, which is equivalent to 6 pi over 3. And I get the angle 2 pi over 3. So 2 pi over 3 is coterminal with 14 pi over 3. It's also coterminal with 8 pi over 3. Initial side, terminal side, same position. Alright, even when they're negative. Let's say it was negative 13 pi over 6. And you need to find a coterminal angle with this angle that has to be between 0 and 2 pi. Well, I'll just add 2 pi. Negative 13 pi over 6. And when I gotta do common denominators again, I'm multiply 6 over 6 here. So I add 12 pi over 6, and I get negative pi over 6. Negative pi over 6 is coterminal with negative 13 pi over 6. And if you want an angle that was between 0 and 2 pi, I can just take that negative pi over 6 and add the 2 pi. And here we go. 11 pi over 6. 11 pi over 6, negative 13 pi over 6, coterminal angles. Lastly, sometimes just drawing a diagram really helps you become familiar with all these angles and radian measures. So I'm just going to draw the Cartesian plane here, everyone. X, Y axis. Let's start with the 0 degrees or 0 radians, and then when pi is 180, so that would be an angle starting here, rotate 180 degrees. What's half of this? Half a pi, that would be here, 90 degrees. So 1 pi over 2, 2 pi's over 2, 3 pi's over 2. If an angle rotate all the way around, it would be 4 pi's over 2, which is 2 pi radians. Sometimes just making a sketch like this really helps us become familiar with these. Notice again, I'm going to do these 30 degrees, the pi over 6. So 30 degrees, pi over 6, that's about, 1/3 of the way to here. So just estimate, and then another 30 degrees. So I'm just going to do 30 degree increments. Maybe 30 over here, 30 over there. I'm going to take this marker, I want to just go right through the origin. Do it again. Right through the origin. And one more. Boom. Let's find all these. Alright. Angles in standard position. Initial side right here, terminal side lands somewhere else. Let's say it was 30 degrees, which is pi over 6. Alright. Well, then this should be another 30 degrees, which would be 2 of these. 2 pi's over 6. 2 pi over 6 reduces to pi over 3. 3 pi's over 6, that's pi over 2. 4 pi's over 6. That reduces to 2 pi over 3. 5 pi's over 6. 6 pi's over 6. That's pi. 7 pi's over 6. 8 pi's over 6. That reduces to 4 pi over 3. 9 pi over 6. 10 pi over 6. That reduces to 5 pi over 3. 11 pi over 6. And finally, 12 pi over 6, which would be the 2 pi. Alright? And just a diagram like this helps you become familiar with this. So that 4 pi over 3 we were talking about earlier. An angle's in standard position. Starts here, rotates this way, its terminal side is right here. Okay? Oh, let's do the pi over 4s also. Pi over 4, everyone, that's 45 degrees. That'd be halfway between here and here, its terminal side. I'll put there and just go right through the origin. That'd be halfway between here and here, another one. Alright, that's good enough. So this is pi over 4 radians. That would be 2 pi's over 4, which is pi over 2. This would be 3 pi's over 4 radians. 4 pi's over 4 would be at pi. 5 pi's over 4 would be right there. 6 pi's over 4 would be right here with the 3 pi over 2, because that's what it reduces to. And 7 pi over 4 would be right there. So yes, if you had to sketch an angle in standard position that was equal to 7 pi over 4, knowing this diagram, you're like, it'll just start right here and rotate to right there. So you're familiar with these angles. And that's it.